plus 2 equals 7, is it?
Pretty close to that, yeah. So let's start with a real super easy one. Again, we're solving for x. All these things say solve. Okay, so
So,
now Tiffany, you know that's supposed to be an O because I said solve. All right. So let's do this. Let's do this one. It's 5y minus 4 equals 11. All right. Go ahead and do that. You do it right now. I'll give you 2 seconds to do it. Okay, you had time to do this. Let's do it real quick. First thing you did was add a 4 to both sides. Now, why did you add a 4? How did you know to add a 4?
magic.
Tiffany, you're on a roll today, aren't you? All right, what? Tell me. Do the opposite, right? Okay. First thing you want to do, now look, you want to get y by itself, don't you? That's the whole key to this. You want to get y by itself. So you got to get rid of the 5 and you have to get rid of this minus 4, correct? How do you know which one to get rid of first? To tell you the truth, it really doesn't matter. But with that said, it doesn't matter which one you get rid of first, but it's way, way easier to get rid of one particular one, and that would be the constant, the thing that's being added or subtracted. That's how I usually say it. Whatever's being added or subtracted to that y, that's what you want to get rid of first. Everybody hear me? Get rid of the constant first. The 5 is not a constant. The 5 is being multiplied. We call that a coefficient. Okay, this is just being added or subtracted as a constant, so we get rid of that first. How do you get rid of it? You always do the opposite. You always do the opposite. This is pretty basic, pretty simple. You did this in pre-algebra. You did this in Algebra 1. You did it in geometry. I know, I taught geometry. You did a ton of it in geometry. You did a ton of it in Algebra 2. So this should not be the first time that you've seen this. All right, so, but I'm just going to start from scratch, basically, just in case, just because I'm not sure exactly where we are all on the same level or not. All right, so we add a 4 to both sides because we have to get rid of this constant. You get rid of it by doing the opposite. The opposite of subtracting is adding. We do it to one side, do it to the other side. Remember that rule? Whatever you do to one side of the equal sign, you do it to the other side. Now, some of you guys might have done like this. You might have put like actually, usually it goes right through the equal sign, like that, a little squiggly, but anybody do it like that? Put the line in between? Okay, you might have been taught that way. I never really taught it that way, and that's okay at first. It's okay when you're in pre-algebra and Algebra 1 to put the line, because what this does, if you haven't seen this before, what this does, it kind of gives you a visual representation of the left side and the right side. Okay, you draw a line right down where the equal sign is, and it kind of makes it easier to see the left side and the right side. All right, but at this point in our math career, juniors and seniors taking college algebra really shouldn't be putting that line down like this. You should be working this without that line. Now, am I going to let you put the line here? Of course. If you want to put the line, and if that helps you, that's fine. But try to wean yourself off of that, all right? Because big kids don't do that, okay? When you're in college, you won't see kids in college putting that line down the middle and solving both sides, okay? Even in upper level high school math, you don't usually see that. Now, is there anything wrong with putting the line there? No, there's nothing wrong with it. It's just, you just don't need it, okay? So I'm not going to put the line. So you add a 4 to both sides. What happens here? That cancels out, and that's 5y equals 15. Now you look at this. How do you get rid of this coefficient? Well, what is that 5 doing to the y? It's doing what? It's multiplying. So what's the opposite of multiplying? We divide. So we divide by 5. Don't divide by 5y. I've seen people do that. You're trying to get y by itself, aren't you? So you're just trying to get rid of the numbers that are with the variable. Everybody paying attention and listening? I see people minds wandering already. It's too early for that. We can't have that. So everybody look up here. I know it might be real basic, but I'm saying some very important things because we're going to do some problems that are a little bit more complicated than this, but some of the same things I'm saying for this easy problem are going to be used on the more difficult problems. So hang with me, all right? Don't let your mind go somewhere else. Let's focus. Let's concentrate. Let's write every step down. Listen to the things I'm saying. I'm very careful in how I'm explaining this problem because I know what we're going to do a little bit later, and I know what we're going to do a little bit later is a little bit more complicated than this. All right, so this is not the way it's always going to be. So don't just sit there and just eyes everywhere else. You can't have that. So watch. I don't get rid of the y stays there. I get rid of the 5. I get rid of the number that's with the y, so I just divide by 5. Do that to both sides. The 5. Now look, why do they cancel out? Now we say cancel out for both of these, but they're doing two completely different things. What is this -4 and this +4 doing to cancel each other out? They're adding up to 0. Very good. I've said that 100 times in here this year, haven't I? When they get rid of this stuff. What's going on right here? What is that 5 and 5 doing? Are they adding up to 0? Okay, they're canceling out, but they're doing what? They're dividing out to be a 1. And then 1 times y is just y. Okay, do you understand why they cancel out? I don't mind you saying cancel out, but I think it's very important that you know why they cancel out. All right, so they cancel out because they both are divided. 5 divided by 5 is 1. 1 times y is y. And then just divide that, and that's a 3. All right, everybody good with that? Who got 3 on their own when I asked you to do it by yourself? Okay, very good. All right, let's do another one. Now, they're going to get, just a little bit more complicated as we move on. So I think you probably understood that anyway, didn't you? Let's do another one. We'll do it right here on the same page. So write this down. 2x minus 4, and then equals 7 minus, and then x plus 5. Now there's a couple things that are different about this than this. Look what this one had right here. That just had one variable, didn't it? It just had one y. It was already on the left-hand side. We didn't have to move anything around. So we just got rid of these two things, the minus 4 and the 5. This right here, look what I have. I got an x on one side, got an x on the other side. So that's a little bit different. I also have something else that's a little bit different, don't I? Look at this 3. What do I have to do with that 3 before I do anything else? Distribute it through, okay? So let's do that. Let's take that 3 and let's distribute it, and let's see what we get. Well, what about the other side? We'll do that in a second, but what about this other side? Do we distribute the 7 through here? No, the 7's not being multiplied, is it? What's being multiplied by this parentheses? Just the negative, right? So I just take that negative, and then I distribute that negative through. Everybody see that? All right, that's very important. So let's do this. So distribute. Now, remember what I said earlier? A lot of the stuff we did in the first chapter we're going to do in this chapter right here. So this is one of those things. We learned how to distribute in that first chapter. So now we're going to go ahead and use that skill to solve for x. So this is going to be 6x minus 12. Now this 7 is not being distributed. I'm just going to keep that as 7. But you are distributing a minus through here. It's minus x, and it's also what? Minus 5. Don't forget that. That's, out of teaching this for years and years and years, that's a mistake a lot of people make. They forget to distribute it through that second one as well. Make sure you do that. Now what we have, now look at this. This left side in this first problem was already simplified. There was nothing we could have done to simplify this any further. We can't add them up. And I've seen some of you guys do that in the last chapter that we've done. I've seen some of you guys try to take 5y and 4 and add them together. You can't do that because you can't add what? Unlike terms. Okay, you can only add. I should have said it like this. You can only add like terms. You've heard that phrase a million times, haven't you? Only add like terms. So you can't add those together. So what we do is we look at both sides. Is there anything we can simplify on this left side? Can I add those two together? No. So I'm just going to keep it at 6x minus 12. What about this side over here? Can I add anything over here? The 7 and the minus 5, exactly right, because they're like terms, so let's add them together. So I got 7 minus, so it's a positive 7 and it's a minus 5. So 7 minus 5 is 2. And then this x is a minus x, and I bring that down. See what I did? So in that step, the only thing that I did was just add those two things together. So always add up, or always simplify both sides first. Before I start trying to solve for x, I haven't even thought about solving for x yet. Okay, all I've done was just try to simplify both sides. How did I simplify the left side? Just distribute. And then, after I distributed, it was already simplified. What about this side over here? How could I simplify that? Well, I distribute the negative and I add the like terms. Everybody see that? So both sides are now completely simplified. Now, I'm ready to get the x's on the same side. So over here, the y was already, there was just one y, it was already on the left side. Now I could actually put the x's on the right side, or I could put them on the left side. It doesn't make any difference. I think one way is easier than the other. So what do you think you would do? What was that? Let's move the x's. Well, let's move the x's first. Let's move the x's first. I mean, you could do that. It's not wrong what you said, but I like to move the x's first. Yeah, I would add an x, okay? Because I would get this x over here on the left-hand side. Now, some people, it doesn't matter what the problem is, they always want to put the x on the left-hand side. That's okay, I guess. I kind of like to put the x on the side that's going to keep it positive. You hear what I said? We're going to do a problem in a minute, where I might want to move the x to the right-hand side just because I want to keep it positive. Does it have to stay positive? No, not at all. To me, it's a little easier to work with it if the x was positive. So look, I could have got rid of this 6x. How could I gotten rid of that 6x? It's a plus 6x, so I could have subtracted the 6x, couldn't I? I could have subtracted the 6x from here, but what would I get on the right side? I'd get a what? A negative 7x, wouldn't I? And there wouldn't be anything wrong with that. That would be okay. But I just think it's a little easier if I took this and moved it over to the left-hand side. Watch. I can add an x here. I can add an x over here. Everybody see that? That's going to give me a positive 7x on the left-hand side. What would you rather deal with, a positive 7x or a negative 7x? I think most of us would rather have a positive 7x, wouldn't you? Okay. All right, so what happened here? That canceled out, or they added up to 0. Now, a lot of people just bring everything down and then do the next step. On this particular problem, I'm going to go ahead in the same step. Since I have x on the left-hand side, I'm going to take this constant and move it over to the right-hand side. So, Tiffany, what would I do here? How would I take this minus 12 and move it over?
Plus 12.
Good. I would add a 12 to this side, and then I would add a 12 to this side. How did I know to add? Because that's the opposite of subtraction. Okay?
You almost lost me for a second because I was finishing up the
Oh,
problem.
okay. Are you on track now? Good. All right. Simple yes would have been okay. All right, so let's do this. Let's add our stuff together. That added up to 0, didn't it? Canceled out. All right, so I like to do that. I like to mark them out so I know that they're gone. So 6x plus 1x is 7x equals 2 plus 12 is 14. Now it's really simple, isn't it? Divide both sides by 7, and then x is 2. Look what I did. I showed all my steps, didn't I? I didn't try to do anything in my head. I showed every little step I could possibly show. I didn't leave anything out. All right. Now, there may come times when our problems are a little more complicated. There might be a couple things you can just do in your head and then write down the next step. But in this problem, I think it's very important that you show every little step. We good with that? All right, let's do another one. Okay, here you go. And again, these problems, I'm not writing it every single time. I'll write it this time since we've got a blank screen here. So it says solve. Now, it's pretty obvious what you have to solve for, isn't it? You solve for k because that's the only variable. All right, so what do we do first? Well, we need to simplify both sides, don't we? So look at the left side. All this stuff is on the left side right here. So we have to simplify that first. Well, really, what are the only things that we can simplify? Is adding these two like terms together, right? Because this has k and this has k. So look what we have. We got fractions. I've been harping all first chapter about knowing how to add fractions, and this is one situation where you need to add fractions together. All right, so let's do this. Look, this is 2 over 1, isn't it? So we find a what? Common denominator, which is 6. Did I do anything to this 6 to get the 6? No. So I keep that a 5. Right? It's actually a 5k. All right, and what about this? 1 times 6, so 2 times 6 is 12, right? Everybody see that? Look, 12 over 6, and that's the same as 2? Yeah? Everybody does that make sense? I just took that 2 over 1 and made it 12 over 6. All right? This is how I decided to do it. You could have split it up into 2 separate fractions, had 6 as the denominator for both of those, but I don't know. I just like to make it one common denominator like this. Tell you what. We'll just write this down. We'll do this in the next step. It really doesn't make any difference. So all I did was just add these two things together right there. Everybody got that? Common denominator, all that. Now we can actually simplify this. It's 5k minus 12k. 5 minus 12 is negative 7k over 6. So I simplified that, didn't I? Just went 5 minus 12, basically. What about this 1/3? I have to get rid of that 1/3, don't I? So it's being added, so what's the opposite of adding a third? Subtract a third, right? So I subtract 1/3 here, subtract 1/3 here. Now this fraction is easy, isn't it? Because it's already a common denominator. 2/3 minus 1/3 is 1/3. Good. I'm going to go different color here just so it stands out a little bit. Now we have this k we're trying to get by itself. Look at all the stuff that's on the same side with the k. Well, you got a negative 7 and you have a 6, don't you? So you have to get rid of both of those things. Let me ask you this first. Let's take a look at the 6. What is this 6 doing to this k? Is it adding, subtracting, multiplying, dividing? What's it doing? It's dividing, isn't it? So what's the opposite of dividing? It's multiplying, isn't it? So how can I get rid of this 6 on the bottom? Multiply it by 6, put it on top. Everybody see that? look what's going to happen. The 6 will cancel out with the 6. Would you agree? What else do we have to get rid of? Come on, talk to me now. What? The negative 7. It's not just a 7, it's a negative 7. What is that negative 7 doing to that k? Is it adding, subtracting, multiplying, dividing? It's multiplying. How do we get rid of something that's being multiplied? We do the opposite, which is divide, right? So we divide by negative 7. How can I show that? Put that down here on the bottom. See what I just did? Look what's going to happen. Do you see why it works? Because this negative 7 will cancel with this negative 7. Okay. Orders for what? Magazine orders? Anybody have any magazine orders? No, don't think so. Sorry. That was a little scary. I didn't know that guy. All right, so 6 over negative 7. We good with that? Does that make any sense? Look what we basically did. Look at this. This was negative 7/6, right? What did we do to that negative 7/6? We multiplied by the reciprocal. All right, so if you want to think of it that way, that's a good way to think of it as well, right? A lot of people say, oh, divide by negative 7/6. Well, yeah, you can technically do that. But what's the same thing as dividing by negative 7 over 6? It's multiplying by the reciprocal, multiplying by 6 over negative 7. Make sense? That's the part that a lot of people have struggled with, so I wanted to take a little bit of time with that. Now, if I did that to this side, then I have to what? Do it to the other side. Good. All right? Hope you're okay with that. If you have questions, ask me. So look what happens to the 6's. They canceled out. Look what happened to this negative 7. That canceled out with that one. Look what I'm left with. I'm left with a k. That's what I wanted, isn't it? Don't get rid of the k. Don't put the k on the other side. Keep the k right there. Just get rid of the numbers that's with the k. Now, what can we do here? We could just multiply straight across, but I see a little bit easier, don't you? 3 goes into 3 once. 3 goes into 6, what? Twice. Everybody with me on that? And then now you can multiply straight across. So what is that? It's negative 2/7. And that's your answer. Don't put it into a calculator and give me a decimal answer. I'm not going to accept it. I will not accept a decimal answer for this. Everybody hear me? Okay. I want a fraction answer. Now, sometimes it might come out to like a half. If it came out to like a half and you put 0.5, that'd be all right. But don't put this into a calculator and get some, crazy decimal. All right? Just keep it like this. There's no reason to. I mean, you're just wasting your time by taking this and putting it into a calculator anyway. And plus, the calculator will give you an inexact answer. All right? This is an exact answer right there. We good with that? All right. We got time to do one more. Let's do another one. Let's, okay, I see another one. Let's do this. Let's change colors first. Let's go green. All right, let's try another one. This one's got a fraction as well. It's kind of like a combination of that second problem we did with that distributive property and the one we just finished doing. Everybody see that? So you got distributing, don't you? But then you also have some fractions. Don't think you're going to get away from working with fractions, okay? I know it's not your favorite thing in the world, but you're going to see it a lot. So you might as well learn how to deal with these fractions. All right, let's take a look. First of all, what do you think the first thing that we're going to do here is? Take that 1/7 and do what to it? Distribute it. That's right. So we'll distribute the 1/7, and then in the same step, we'll distribute the 1/5. Now, how in the world would you write this? 1/7 times 3. What's the best way to write that? It's not 3 and 1/7. It's not 3 plus 1/7. Think of this as 3 over 1. What would you do? Multiply the top, multiply the bottom, right? So it's what? 3 over 7, right? Everybody see that? But this does have an x with it, so we'll stick an x right there. Minus. Do the same thing here. Again, this is 2 over 1. So what's 1/7 times 2 over 1? Multiply the top, multiply the bottom. What do you get? 2 over 7. Everybody with me on that? Okay. Equals. Let's do the same thing here. 1/5 times x is the same as, remember, think of this as x over 1. So this is going to, you could put 1/5 x, or you could put x over 5. Either way would be okay. I'm going to write it like that. And then plus, what's this going to be? 2 over 5, right? Put it over 1. 1 times 2, 5 times 1. Okay? Now what do we have to do? both sides are simplified, aren't they? I can't add these two together. I can't add these two together. So if I look at this, I got an x on the left-hand side and I got an x on the right-hand side. That means I'm going to have to take this and I'm going to have to move it over. So how do I move this x over 5 over to this left side? Remember, you're not just getting rid of the 5 here. You have to move that whole entire term over to the left side. So what is that whole entire term doing? Well, it's adding, but we have to get rid of it by subtracting, right? Okay? So we subtract an x over 5. So come over here and subtract an x over 5. If you wanted to, you could write it 1/5 x. That may actually, now that I think about it, might be a little easier for you. Same thing, isn't it? 1/5 x and x over 5. So look, that cancels out. Now we got the x on the left-hand side. Now we're going to have to add those together, though, aren't we? And this time we have different denominators. We're going to have to find a common denominator. Let's do this in the next step, though. Let's get rid of this minus 2/7. Since I have the x on the left-hand side, let's take the constant and move it to the right-hand side. So how do I get rid of this minus 2/7? Plus 2/7. Good. And then I do the same thing over here. And you see I've got to add some fractions over here as well, don't I? So let's do that. Let's do it the old-fashioned way. Remember how you used to do this when you were young? You first learned fractions. What would your common denominator be with 7 and 5? 35. There's several different ways you could approach this. You could have put one fraction like this and figured out the numerator, but I just decided to go like this. It might make it a little easier for you. It might be a little more recognizable. So what'd you do? 7 times what? 5. So 3 times 5 is 15. What's this one? 5 times 7. So 1 times 7 is 7. But look, this is a negative though, isn't it? So you got to make sure you put a minus here. Right? Just basic common denominators. Alright? Nothing real crazy with that. We'll do that in a second. Let's do the same thing over here. What would my common denominator be with these? Same exact thing, right? 35. So 5 times 7, 2 times 7. And the denominator is 35. 7 times 5, 2 times 5. Now this is add, isn't it? You are adding those together, so you're going to add them just like that. Alright? Hopefully you understand what's going on here. Now this all has an x here. I forgot to put the x. I need to put the x there. So what do we got? We got 15 over 35 minus 7 over 35. So 15 minus 7 is 8 over 35, and there's an x. Equals, remember these canceled out. These canceled out. What do we get here? 14 over 35 plus 10 over 35 is, 14 plus 10 is 24 over 35. If I'm going a little too fast, go back tonight, look at it on the video, and take it step by step. Now, we've got the same kind of deals we had in that last problem. We have to get rid of this 8 over 35. So we multiply it by the reciprocal. That's right. So 35 over 8. Now why do we do that? Because look, the 35s cancel out and the 8s cancel out, don't they? If I do that to the left side, I have to come over here and do that to the right side. So multiply that by 35 over 8. Oh, they've kind of rigged this, haven't they? So it comes out a little bit nice. Watch what happens. The 35s cancel, the 8s cancel. I'm left with x. Look over here. Does anything cancel out here? Yeah, don't go 24 times 35. That'd be crazy, wouldn't it? Right now, you see it. 35 and 35 cancel out. What about the 8 and the 24? That reduces as well, doesn't it? So 8 goes into 8 once. How many times does 8 go into 24? 3 times, right? Because 8 times 3 is 24. And then that's it. X equals what? 3. Just like that. There may be other ways to approach this problem. I think this is probably the most straightforward way to approach it that you should be able to handle. Alright. It's 5 till... Let's do one more problem. Okay, this will help you out, because I saw a problem on the worksheet that you may want to do. Now, I don't see one in the book that's like this. Tell you what, I'll make my own up. Is that alright? I don't know if it's going to come out. It'll probably come out ugly, but that's okay. They're not always going to come out real nice and pretty. So let's just go like this, and let's go like this. I have no idea if this is going to work out or how it's going to work out, but let's see what we can do. Now, there's a couple ways you can approach this. This is how I would do this. What I would do is look at this whole sum up here. You're dividing by 2, aren't you? First thing I would do, that whole thing is being divided by 2. So let's get rid of this 2 on the bottom. Well, it's being divided by 2, so how do we get rid of that? Multiply by 2. So watch what I'm going to do. I'm going to multiply by 2. If I do that to this side, what do I have to do over here? Multiply by 2 on this side. Agreed? I'm going to put a parentheses here because that 2 is going to be multiplied by this parentheses. So let's see what happens now. So the 2 cancels out here. So what am I left with? X plus 4 equals x minus 8 in parentheses times 2 over what? 3. Now I'm doing this in 2 steps. You may want to get rid of the 3 in the same step, but I'm trying to make this as clear as possible. So now look what we can get rid of. I got to get rid of this 3. Well, this 3 is being divided by all this stuff right here, so how do I get rid of that 3? Multiply both sides by 3. Put that in parentheses because we're multiplying a sum by 3. We did a lot of that stuff in the first chapter. Now look what happens. That 3 cancels out with that. Now look what you've got. Now you have this. Now you might be able to do this right out this next step, but I'm going to do it like this. Everybody see that? I just put the 2 on the left-hand side just to make it look a little nicer. See what we did there? Basically, what did I do? I just took this 3 that was being divided and I stuck it up here at top on the other side. Then I took this 2 that was being divided and I stuck it up here on the other side. You see that? You may be able to go directly from that to this, but I wanted you to see why you got from here to here. Does that make any sense? Look, this 3 was on the bottom on the other side. How do I get rid of it? Just put it on the top on the other side. You see it? Okay, this is on the bottom on the right. It's going to be on the top on the left. Look at this 2. This was on the bottom on the left, so where's it going to be? On the top on the right. Do you see it? And that's what it ended up to be. And then from here, you could just do that. I'm not even going to do that. You can just do it. You know, distribute the 3, distribute the 2, solve for x, and there you go. Yes.
Wouldn't it be 6 though?
Where's that? Right here?
Because yes.
No, because that 3 canceled out with a 3. It'd be 6 over 3, right? But then the 3's would cancel out. It would leave you a 2 anyway. Okay? I probably went a little bit too far on this step right here. I just wanted to show you how to get from here to here. And you're going to have a problem on the homework that looks just like this. Number's a little different, but it looks just like that. Okay? So we are doing section 2.1, and it's worksheet A. All right, and that's your homework. There are 10 of those problems, and I'm looking at it, and they pretty much all look like what we've been doing, pretty much. Okay? All right, enjoy your first homework back from Thanksgiving break.